Okay, this is the second example of finding K using a RIChE Conc table. So to be able to use a RIChE Conc table for this particular example, if you're given the moles initially and then the mole of one chemical at equilibrium, you can use that table to find the equilibrium concentrations of all the reactants and products and then find your equilibrium constant. Okay, so I talked about this in the last one. Heinemann uses X's and 2X's. That's fine if it's a 1 to 2 relationship, but I'll do mole ratios in case it's something else. This example, at a particular temperature, we've got 0.0500. Last time I forgot to mention significant figures, so how many significant figures does that have? It's got 1, 2, 3. First, as soon as you hit a number, every number after that, every zero after that is significant. So theirs have all got 3, that's got 4, and that's got 4. So you use that's got 3. You use the least number, so your significant figures at the end would have to be 3. And if I haven't got 3, I'll have to stop this and fix it. All right, so analysis showed that at equilibrium, you've got 0.14 mole of sulfur dioxide. So you started with 0.15 of the product, and you end up with 0.14 of the product. So which direction has the reaction proceeded overall? What's the net direction? Okay, so hopefully you worked out that, don't go back. Can you set up the table? Can you remember what the table looks like? So it's a RIChE Conc table. What does the R, the I, the CH, the E, and the Conc stand for? Okay. So ratio, initial mole. All these things are moles, and the last one's concentration. So it's moles that you start with, moles at equilibrium, and you're working out basically what's gone on. Which way is the direction gone? So pause it here, try and pause it as much as you can, fill in it all as much as you can, and then check. Okay, so ratio, it's a 2 to 1 to 2. We have 0.05 of that, 0.01 of that, and 0.15 of that. And then we have, at equilibrium, 0.14 moles left. I've just cut off my significant figures because I couldn't be bothered filling it all in. Okay, so first thing, we have to work out which direction. So if we started with this and we ended up with less, clearly there has been a net back reaction. So we're going to use up some of this and make reactants. Okay, so we're going to have to take some amount of that away and add it to our reactants. All right, so clearly this is pretty easy. I hope you can work that out, that you've lost 0.01 moles of this. When we're adding it, we don't just add 0.01 moles here, 0.01 moles here. We have to take account of the mole ratio. So it's a 2 to 2, so you're going to add 0.01 moles there. But this one, let's do it, go over the top, and you probably do it in your head. But what you want, our mole ratio, what you want on top, what you've got. So you want oxygen, you've got sulfur trioxide, and it's a 1 to 3 relationship. Set up your mole ratio, then take that over the other side and fill in the right numbers, and you can see that you've got a half. Okay, so you need to be able to do this. Do it on the side perhaps in case it's not a 1 to 2. Okay, so you've used up this and formed 0.01 moles of that and 0.005 moles of this. So hopefully you could work out at equilibrium, if you started with this amount of sulfur dioxide and you added that amount, that you would end up with 0.06. If you started with this and you added that you would end up with this. Okay, so now once we've got our moles at equilibrium, we just need to find our concentration. Remember, that's why we need this conc, so we don't plug those numbers in and use them to find K. So number of moles on volume is concentration. Number of moles on volume, number of moles on volume, and you've got your moles per litre. And then we plug it into K. What do we put on top? Which one of these? Your products. And don't forget that you have to use your mole ratio numbers, put all the numbers in, and this is how much you get. And I think I said at the beginning it was 3 significant figures. That's right. Yep. This is squared, so you got M, 2 M's on the top, M squared, and another M. So you've got 3 M's on the bottom. So if you cancel out 2 from the top, 2 from the bottom, then you've got 1 extra. So it's 1 over M, so M to the minus 1. Okay, 5 minutes.